welcome to the next session of Strength of Materials. In this session, I will discuss about bulk modulus, some relations between the elastic constants E, K and G and a numerical based on it. So let's start with bulk modulus. If a body is subjected to three mutually perpendicular like stresses, either all tensile or all compressive stresses of the same intensity, then the ratio of direct stress to the corresponding volumetric strain of the body is constant and is known as bulk modulus. It is denoted by K. Now, long story cut short, if you see this diagram, this is a rectangle. I have shown three stresses. All the three stresses that I have shown are of tensile type. It could be of compressive type also, but all three have to be necessarily either all tensile or all compressive type. Then in that case, when you take the ratio of this direct stress to the volumetric strain in the body, that is called as bulk modulus. If you observe this term delta V by V, volumetric strain, it has no unit. The unit of sigma is going to be either Newton per mm square, kilonewton per mm square, kilonewton per meter square, Newton per meter square, and hence is the unit of K the same because it has only one term to the right containing the unit. Next, I'll take up the relation between modulus of elasticity and bulk modulus. Modulus of elasticity is Young's modulus E and bulk modulus is K. So let me start with volumetric strain delta V by V. The equation for this is sigma x plus sigma y plus sigma z upon E. I am talking about a triaxial loading and I multiply with 1 minus 2 mu. Suppose if sigma x becomes equal to sigma y becomes equal to sigma z in magnitude, so I call it as sigma, then here I will get 3 sigma upon E into 1 minus 2 mu. This is my delta V by V. I'll mark this as equation 1. We know the equation for K, which we just read, is direct stress sigma upon delta V by V. So when I substitute this delta V by V from equation 1, I get sigma divided by 3 sigma upon E into 1 minus 2 mu. So here this term sigma gets cancelled and E gets multiplied above. So E upon 3 into 1 minus 2 mu is my K. Therefore, I will write E is equal to 3K 1 minus 2 mu. This is the equation which I was using in my previous lecture. So this is a very simple derivation for the relation between E and K. Next, I will derive a relation between the three elastic constants E, K and G. We have just seen E is equal to 3K 1 minus 2 mu. This is one equation that I am going to use. There is another equation which I am going to use, that is E is equal to 2G 1 plus mu. This equation I am not deriving for the moment. So from this equation 2, suppose if I calculate the value of mu, I am taking the term mu on one side. So I get E upon 2G is equal to 1 plus mu. Therefore, I get mu is equal to E upon 2G minus 1. Let me mark this as equation 3. Suppose if I substitute 3 in equation 1, substituting equation 3 in 1, therefore I'll get E is equal to 3K 1 minus 2 into 2 upon, it is E upon 2G, E upon 2G minus 1. When I multiply, I'll get 1 minus, this 2 and 2 gets cancelled, so the first term is E upon G, and when I multiply the term here, I am going to get plus 2. So this is 1 plus 2, 3. So I'll get 3K into 3 minus E upon G. This is E. So E is equal to, this becomes 9K minus 3K E upon G. When I take G as a common LCM, I'll get 9kg minus 3ke upon G is E. So therefore, when I cross multiply, Eg is equal to 9kg minus 3ke. Now here if I take the E terms together, I get Eg plus 3ke is equal to 9 kg. So here if I take E term common, I get G plus 3k is equal to 9 kg, and when I have to write E on one side and rest of the terms on the other side, so I get E is equal to 9 kg upon 3k plus G. So this is the relation between the three elastic constants E, K and G. Next I'll take up a numerical. For a round bar of 50 mm diameter and 2.5 meter long of a certain material has Young's modulus of 1.1 into 10 raised to 5 Newton per mm square, and modulus of rigidity is also given. So I will write down the data first. It's a round bar, diameter is given as 50 mm, the length is given as 2.5 meter, which is 2500 mm. The value of E is given as 1.1 into 10 raised to 5 Newton per mm square, and the value of G is 0.45 into 10 raised to 5 Newton per mm square. Find the bulk modulus. I need to find K and lateral contraction of the bar. If you understand, this is a circular cross section and this is the length. If I apply the load like this, it is written here when the bar is stretched by 3 mm, which means delta L is given to me as 3 mm. So I need to calculate the lateral contraction in the diameter. So to find, the first term is K and second term is delta D. Now in this I cannot use directly the relation of E and K because I don't know the value of mu, but I know the value of E and G. So I can use E is equal to 2G 1 plus mu. E is 1.1 into 10 raised to 5 is equal to 2 into G is 0.45 into 10 raised to 5, 1 plus mu. So here I'll get the value of mu as 0.222. Now I can use the equation of E and K. So E is equal to 3K 1 minus 2 mu. Therefore I'll get 1.1 into 10 raised to 5 is equal to 3K 1 minus 2 into 0.222. I'll get the value of K as 0.659 into 10 raised to 5 Newton per mm square. So this is the value of K that I obtained. This is the first answer that I've got. Next I need to calculate the value of delta D. Now I know the value of mu. I know that mu is lateral strain to the linear strain. So let's use that equation. Mu is equal to lateral strain to the linear strain. So here I'll write down delta D by D for lateral contraction, and for linear I'll write delta L by L, which is mu. I know the value of mu is 0.222. Delta D is not known. I know the value of D is 50. The value of delta L is given to me as 3 and the value of L is also given as 2500. So I can very easily calculate the value of delta D as 0.0132 mm. So with this I end the session. The numerical is very simple, and in the previous lecture I have also shown you some use of EG and EK relation. So I'm not solving more numericals on this. It's quite easy. So I hope you have understood the session. If you have any doubts or you want me to solve any numerical, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. I'll see you in the next session. Thank you.